Now this is a simple question because in column 1 you have 1, 2, 3. So by applying, R2 if you replace by R2 minus twice R1, and similarly if you replace R3 by R3 minus 3 R1, so you get 2 zeros in column 1, it will be easy to evaluate. So let us apply, take left hand side, that you rewrite 1, 2, 3, 1 plus P, 3 plus 2P, 6 plus 3P, and you have 1 plus P plus Q, the elements of third column, 4 plus 3P plus 2Q, and 10 plus 6P plus 3Q. Okay. And now as I discussed with you, you apply, replace R2 by R2 minus 2 R1 and replace R3 likewise by R3 minus 3 times R1. See what you get. Keeping of course the elements of row 1 intact. So you have elements of row 1, 1, 1 plus P, 1 plus P plus Q. Now elements of row 2. So it is 2 minus twice 1 will make it 0, and 3 plus 2P minus 2 minus 2P will give you 1, and similarly in the third element of second row will leave 2 plus P. And now similarly applying R3 minus 3 times R1, you will get 0, 3 and 7 plus 3P. Obviously now we can expand it along C1. So expand the determinant along C1. You get 1 time 1 into 7 plus 3P and minus 3 into 2 plus P. So you get multiplying by 1, outside 1 will not matter. So you left with 7 plus 3P minus 6 plus 6 minus 6P. So here this 7, just wait, you get minus 6 and minus 3P. Make a correction please, minus 3P. So the 3P and 3P will cancel and 7 minus 6 will give you 1, which is the required right hand side. We have to prove it equal to 0. When is the value of a determinant is 0? If either any two rows or columns are 0, or they are equimultiple, or there is a third possibility, if somehow we could reduce all the elements of a particular row or column as 0, then the value of determinant will be 0. Look at the question carefully. In the third column, you have an element cos alpha plus delta. If you expand it, you get cos alpha cos delta minus sin alpha sin delta. So, whereas in the first column you have sin alpha, in second column you have cos alpha. So then if you expand the elements of column 3 and then with a suitable operations, we can make all the 3 elements of column 3 0. See how we'll do it. Take left hand side in any case. The elements are sin alpha, sin beta, sin gamma, the elements of first column. Second column are cos alpha, cos beta, cos gamma, and the third column are cos alpha plus delta, cos beta plus delta, and cos gamma plus delta. Now you multiply the elements of column 1, multiplying the elements of column 1 by sin delta and that of C2, column 2 by cos delta, and opening the elements of the third column. By opening I mean apply the formula of cos A plus B in all the 3 elements of column 3. Now because we are multiplying the elements of column 1 by sin delta and column 2 by cos delta, so we must keep to compensate it outside, that is 1 upon, we must divide it as a whole. So it is 1 upon sin delta into cos delta outside, and you get what are you doing? You are multiplying the elements of column 1 by sine delta. So you have sine alpha, sine delta, then you have sine beta, sine delta, and sine gamma, sine delta. Similarly, you are multiplying the elements of column 2 by cos delta. So you have cos alpha, cos delta, then cos beta, cos delta, and cos gamma, cos delta. And what are the elements of column 3? Column 3, the first element is cos alpha plus delta. So if you apply cos A plus B formula, you get here cos alpha, cos delta minus sine alpha, sine delta. Similarly, the second element will be cos beta, cos delta minus cos, you will get cos beta, cos delta minus sine beta, sine delta, and the third element will be cos gamma, cos delta minus sine gamma, sine delta. Now what do you do? We find that in column 3, if you add column 1, like the first, this sine alpha, sine delta kind of term will cancel, and you subtract column 2 and you will get 0. So now you replace C3 by C3 plus C1 and minus C2, keeping the first two columns as such. So you have 1 upon sine delta, cos delta as such, in the first two columns you keep as such. What are the elements? You have sine alpha, sine delta, and so on, you rewrite. Similarly, you have cos alpha, cos delta, and the other elements you keep as such. But what about the elements of third column? When you add to the elements of C3 the elements of C1, so the terms like sine alpha, sine delta, cos, sine beta, sine delta, and sine gamma, sine delta will cancel, and then you will left with cos alpha, cos delta. But you are subtracting the elements of second column, that is cos alpha, cos delta minus cos alpha, cos delta will also cancel. So in any case, in the third column you get 0. And if it is so, then outside you have 1 upon sine delta, cos delta, and the value of determinant will be 0. Why? Because as all the elements of column 3 are 0, and if all the elements of any one row or column are 0, then it is 0. So finally the value of the given determinant is 0, which is the required right hand side.